Hello everyone. This is in continuation with our hypothesis testing problems. The next question is, a pharmaceutical firm has just developed two new oral anesthetics A and B. From similarities in the chemical structure of the two compounds, it has been predicted that they should show the same variance in effect delay time. Sample data from tests of the two compounds are given as below. Anesthetic A, sample size is 31, sample variance is 1296. Anesthetic B, sample size is 41, sample variance is 784. Test at a 2% significance level whether the two compounds have the same variance in effect delay time. One thing is very clear that this problem is again related to two population variances. Right. Above or this problem is concerned with comparison of two population variances. Let us say sigma 1 square equal to population variance of anesthetic A. Sigma 2 square is population variance of anesthetic B. We are supposed to test whether both the variances are same. So we will be using F test and null hypothesis will be the same what is to be tested because it has got an equality sign, and alternative hypothesis, since nothing specified about larger or smaller, we will have sigma 1 square not equal to sigma 2 square. So it becomes a two-tailed test. The previous problem was a one-tailed test or a right-tailed test to be very specific. Here it is a two-tailed test. Now, F test statistic, here it is F cal, or we can say F calculated value is S1 square by S2 square. S1 square is sample variance of anesthetic anesthetic A, and then S2 square is sample variance of anesthetic B. Both are given in the question. 1296 and 784. 1296, 780. 1296, 784. And then sample size is also given. Sample size of anesthetic A, and 2 is sample size of anesthetic B. So what is given? 31 and 40. Now our F cal, we know it is S1 square by S2 square, which is 1296 divided by 780. 1.65. Okay. Now, how do we infer For a two-tailed test, we accept null hypothesis if C1 less than or equal to Fcal less than or equal to C2. Now let us describe what is C1 and C2, where C1 is 1 divided by F tab or F table value at alpha by 2 level of significance for N2 minus 1, N1 minus 1 degrees of freedom, and C2 is F table value at alpha by 2 level of significance for N1 minus 1, N2 minus 1 degrees of freedom. So we need to now check what are the corresponding table values. Alpha by 2. Here alpha is given in the question. Level of significance is given as 2% level of significance. 2% by 2. So it is alpha by 2 is 1% or 0.01. So we need to check now for N2 minus 1. What is N2 minus 1? 40, 30. For numerator degrees of freedom 40 and denominator degrees of freedom 30, what is the table value? It is 2.3. So 1 by F table value is 1 by 2.3. That is our C1. So what is that? We get 1 divided by 2.3. 0.435. Now let us check for C2. C2 is a table value for N1 minus 1, N2 minus 1. So this is actually, numerator is 30 degrees of freedom, denominator is 40 degrees of freedom. Numerator 30, denominator 40. It is 2.2. C2 is 2.2 from the tables. Now, inference. What is our Fcal value? 1.645. Does it lie between these two? Yes. Since C1, which is 0.435, is lesser than Fcal, which is 1.645, and again that is lesser than C2, which is 2.2. Since the calculated value lies between C1 and C2, we accept null hypothesis. Means there is no significant difference between both the population variances. That will be our conclusion. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.